We're ramping it up. We're going level 7 out of 10. I don't know if it's actually that. I'm just making shit up. Let's do a problem. I like these games with the roots. So we're going to take a limit as x tends towards infinity. Have some rational function. Ish. We got this root that's hanging out up top. So I asked you, what's the degree of the bottom? Let's start there. What's the degree of the bottom? Bottom. It's 1, right? Degree of the top. What's that? What's the square root symbol mean? Hold up. Let me change it. Doesn't this mean this? The 1/2? So what's half of 2? What's half of 2? Yeah, buddy. Yeah, buddy. It's degree 1. So when you have a square root sitting there, it's basically going to cut your exponent in half to figure out what your degree is. So we actually have the degree is the same both top and bottom. So this is telling us, you know what? Let's go and do a little multiplication of just 1 over x over 1 over x. Except I'm going to write 1 over x a little bit different. This is probably going to blow your brain. Probably going to mess with you a little bit unless you have a firm understanding. So here we go. Now, I'm going to write it, it's 1 over x over 1 over x. That's what we're going to multiply. That's the same thing. Did you know that this is equal to 1 over x? Only if your x values are greater than 0. I talked about that in the first video that I said was optional. It's kind of the talk. It's kind of what we wanted to get down so we could do this and have a good firm understanding of it. So that's the same thing, right? If the x values are positive, the square root of 1 over 2 squared. I wonder what this could possibly be. All right, since our x is 2, it's positive. You're like, all right, it's the square root of 1/4. And the square root of 1 is 1, and the square root of 4 is 2. Oh, yeah, there it is, huh? Wouldn't that make sense? But then we're also going to have some weirdness. Oh boy, howdy, we're going to have some frickin' weirdness. We're going to find out that 1 over x squared is equal to 1 over negative x if your x is less than 0. Go back to that first video if this doesn't make sense to you. Because we're gonna play that game on the next one. So this first one, this isn't necessarily a level 7. We do this because we want to be able to put, if you have the same exponent, you can put your bases together. The exponent is this root. Remember that 1/2 power. Since they both have something to the 1/2 power, we can put them together. That's why we did this. So we say the limit is x tends towards infinity. Let me make my square root all big and bad. And minus 7. And then we get our 2x minus that 5. And now we can bring it in. Since we have the same freaking exponent, the root, we can bring them together and do a multiplication. And that x squared just goes down underneath here. But down below we have a 1 over x, so the x goes down below. Now we can clean it up. Now we can figure out our solution. We could have also just looked at this and been like, do x squared of 3 over 2, which is also a good method. So these go away, just leaving you with the square root of 3. And then we have that minus 7 over x squared all over. The x's go away, so we just get 2 minus 5x, and then play that little thing I showed you. Just like, hey, if there's x's down below, that goes to 0. That goes to 0. What's left over? I won't write the limit this time. We'll just say it's the square root of 3 over 2. We got it. But that shit's weird. We do that when we have roots. And you might be able to kind of figure it out and figure out, like, okay, I can figure out the pattern here. I don't need to show all these stuff. Okay. Cool. Cool. Most common error, sign error. Most common error, sign error. Let's go to our next. It's the same problem, except now we're going to go to negative infinity. So logic tells us, because the numerator ever equals something that's negative? Absolutely not. It's a square root up top. It's got to be positive, at least 0. The bottom, can that be negative? Hell yeah, it's a line. Cool. All right. So we're going to multiply by 1. We're going to multiply by 1, so we're going to do that same game where you say that it's going to be the square root of 1 over x squared, and then down below, that's negative 1 over x. Can you see why? Can you hear my dog? Yeah, it's this. Bang, right back here. You have to change the sign for this to actually equal 1. If we didn't put this negative in here, if we write it like this, and since our x values are negative, that does not equal 1. This shit right here, that does not equal 1. And you can't multiply by anything but 1. You're multiplying by negative 1. You'd be changing the sign. We actually have to have this as negative 1x. Because the top, this is always positive, right? Well, at least it's never negative. Well, actually, no, it's always positive because it can't equal 0 in the denominator. So it's always frickin' positive. But our x values are all damn negative. So wouldn't you have to change the sign down here to make sure you don't have a positive over a negative? Oh, yeah, you do. Go back to that first video if this isn't making sense. All right, now we bring it in. Now we can do our problem. And you can see that our sign is just really going to be the only thing that changes. Take the square root, we write our 3x squared, we write our minus 7, we put our 2x. You can tell I've been writing for too long. This thing has to go in the refrigerator. I have a cooling thing underneath it. It doesn't make any freaking difference. Oops, that's not a square down there. Doesn't make any difference. It just keeps baking. So notice we use the squareds up top underneath the roots, and we use the x down below. Oh shit! I forgot to change my sign. Huh? I forgot to change my sign. So let's make sure we get that changed. Negative, and poof, change the other one to a positive. Let's finish it up. We clean it. So those just went away. Minus 7 over x squared. Okay, that doesn't want to work at all. Okay, so we get negative 2. Oh, that's cool. Plus 5 over x. Once we're here, we're home free. That goes to 0. That goes to 0. And it is leaving us with the square root of 3 over negative 2. So there it is. Negative square root of 3 over 2. Doesn't matter if that negative's down below, up top, out front. It's just negative. And there's our solution. So there's the little root games. This is just a little game we play with roots. And it can get pretty freaking tricky. I'll show you in some, we'll get it up to like a level 9 here in a bit. But I need to just give you a couple of things. Just a couple. And then we'll move on. There's kind of a little off topic. So let us go to here. Let me go. Y is equal. Wow. Let's talk about y is equal to inverse tangent of x. Whatever the hell I just wrote there. Gosh. You'd think I'm coming off a bender or something, huh? Do we know what this looks like? Kind of looks like this. It looks like an S. Kind of looks like an S. And it has some horizontal asymptotes. It's got some horizontal asymptotes here. And the horizontal asymptotes are actually at pi over 2. So this point right here is at pi over 2. And then we have another one down here. And this one's at negative pi over 2. Now we use inverse tangent of x a lot. You can also see it written like this. Arctan. It means the same thing. I typically use this notation here. But arctan, and I know your textbook likes this, so they use it. And anytime you see arc, it means the inverse. So there's your graph of it. And it's basically just a little S. I'm just going to, looks like that kind of. And it's trapped between negative pi over 2 and positive pi over 2. So what we get from that is we get a limit. We get some rules. I don't know why they make this an actual theorem in your book. But we say the limit as x tends towards positive infinity of inverse tangent of x is equal to pi over 2. And the limit as x tends towards negative infinity of inverse tangent of x is equal to negative pi over 2. I use the shit out of this. Know that stuff. That's like that next one. It's one of like 5 graphs that most of us don't know that we need to learn in calculus. That's kind of like it's kind of a hack that's going to get you through. So I think I'm going to stop here so I can put my shit in the refrigerator so I can do the next one. All right, I'll see you.